Okay, so got a new problem here, and we're trying to find the relative min and max. Here's our function up here. It's x plus 1 over x. And so as you can see here, we've got the graph, and of course this graph comes from Google on their search page. If you just type that into the search results, you can get this same graph to come up. Okay, we can see that in this graph here that the graph is increasing, and it's increasing from negative infinity up to somewhere right in here. Right, so here's our coordinates over here, and we can kind of see. So taking a close look at the y value, it's going to max out at, it looks like probably -1. Okay, the x value is -1 and the y value is -2.00. Okay, and then if we look over here, oh, I should say that it's going to be, I guess decreasing. Let's see, increasing and then decreasing from -1 to 0. It looks like, and then we got decreasing from 0 up to 1, and then it starts increasing. Okay, so it looks like we've got a maximum here, relative max here, and a relative min right in this area here. Well, let's do the math. Okay, so our function, and as usual I call everything f of x, is x plus 1 over x. And so now what we're going to do is take the derivative of this, set it equal to 0, and find our critical numbers. Now, I think what I'm going to do here is, what's the best thing to do? I don't know. I think I'll just get this all into one solid fraction. So multiplying x over x over here, so we end up with x squared plus 1 over x. Alright, now we're going to take the derivative of this. So we have f prime of x equals, so take the derivative of the numerator, this is the quotient rule, times the denominator minus the numerator times the derivative of the denominator, and the derivative of x is 1. Okay, and then we put that all over the denominator squared, so we're going to square that. Alright, now what I'm going to do is just kind of clean it up a little bit. So we have 2x squared minus, I'm going to go ahead and distribute this minus through here. So we end up with 2x squared minus x squared, then minus 1. Okay, distributing that negative across, and of course that doesn't affect anything. And that's all over x squared. And of course we can simplify this down. Now what I'm going to actually do here is I'm just going to go ahead and simplify it down and then set it equal to 0. Okay, so 2x squared minus x squared is x squared minus 1 over x squared. So I'm going to take the numerator and first set it equal to 0 and find the solutions to this equation. So it looks like if we were to plug in 1, we'd get 1 minus 1 is 0, so one of our critical numbers is going to be 1. And if we plugged in -1, -1 squared is 1, and 1 minus 1 is 0, so the other one, critical number is -1. Now, we have one more critical number, and that's going to be what makes the bottom down here 0. In other words, if we were to set this equal to 0, the denominator, well, the solutions to this equation here is just 0. So that's going to be our other critical number.